All right, guys. Welcome to RITSEC. Make sure you join the Discord. If you're not in it yet, you need this to sign in so you can get pizza. Everyone's in the Discord. I can hold up for a second. We're all good? All right. Sign in, guys. The sign in should be dropped. You need to sign in because we will have pizza later today. And we will be checking to make sure you have signed in. Check the calendar. Calendar.rittech.club. Join the mailing list as well. And here's for announcements, guys. Oh, did I mess it up? All right. Follow our social media. And meet the sponsors, guys. Clap it up for the sponsors. All right. Thank you. We have IRSEC Blue Team signups. Signups close on the 29th. The competition's on November 1st. And we have Blue Team workshops that are still undergoing. So make sure you sign up. Great opportunity to get involved. If you guys did a co-op this summer, scan this QR code. Good information for us. Yeah, if you have any questions, let us know. And Letchworth trip happening this weekend from 10 to 4. And we also have a mentorship social event, which will be announced that if you're a mentor or mentee, be sure to check the mentorship announcements. Yeah, we'll have more information out there, but it should be next Friday after the general meeting. Also, WESIS is holding Security Summit interest form. If you guys are interested in going to a Security Summit, scan this QR code. WESIS is also funding partial or full reimbursement of certifications. You might have to be a WESIS member for this one as well. Scan the QR code. Oh, there's a voting area for you guys in the announcements channel. So make sure to check out the announcements channel. And today's demos, will be downloaded from the demo help announcements channel. I will be announcing this later as well after the education. Now we have Intro to Networking by Tree. Clap it up, guys. Clap it up. Thank you.
Hello, everyone. Welcome to networking. One of the best topics in security. Don't let anyone tell you otherwise. My name is G. I'm a third year here. Co-op to AWS, do networking and cloud for CCDC. Big fan of the arts. Who's playing Silk Song right now? Whoa. So, why networking in security or in general? Networking is how devices talk to each other. It's how you can access something here in Rochester, New York, and something on the other side of the world. The unified language of technology, nothing would work without networking. I have this analogy here. Not sure if it really makes sense, but these are the core devices in networking. We have routers, which function as your GPS. Switches are like your traffic lights, kind of directing where things should go. Cables are your roads, and devices are things that want to transmit data. The foundation of networking is the OSI model. Oh gosh, I forgot what it stands for, but there's 7 main layers to networking. Each of them have their own function. Recently, you'll see this collapsed version called the TCP IP model, because who cares about presentation in session? We will go over all 7 layers and what they do, though. Starting with layer 1. The physical layer, the good old foundations. These are your wires and your cables. You can have electricity or you can have light, but these are just your physical devices. Kind of all there is to it. It's just a bunch of bits going across wires. Not very exciting, but as we go up the layers, we have your data link layer. This is where we can now work with the bits across the wire and start evaluating what they do. So the logical link control transmits physical media to logical data, and we work with Ethernet frames. And at this layer, we work with MAC addresses. Every device has a MAC address, and it is unique, even virtualized ones. Looks like that. And fun fact, the first three groups actually tell you who manufactured the device. You can actually look it up. Cisco owns like 50 of those groups, the first three octets. Now you're like, okay, Ethernet, cool. What does this do? We wanna, in order to set up the foundation for computers communicating with each other, we have to find out which MAC address belongs to which device. I actually made a mistake here. These are switches, but switches don't use ARP. It's layer 3. So pretend those are computers. But ARP works by broadcasting in a request, asking, hey, who has this IP address? And then a switch will then receive it, and it'll do something called flood the switch, which is transmitting the ARP request to every device on that switch. And if a device has that IP address, it'll respond back, hey, I'm over here. Moving up a layer. The first two layers are really not that great. All the fun is in layer 4, so sit tight, people. Layer 3, the network layer. Here we have IP addresses. These are your 32-bit network identifiers. They're split into a network ID and a host portion. The network ID tells you where a group of computers would be, and the host is a specific device in that network. Here we work with packets. Tells you where you're starting from, where you're going, IPs, and then we hold the data. You might have heard there's something called IPv4 and IPv6. There's some limitations with version 4. It's pretty small. You can only have 4.3 billion addresses. Sounds like a lot, but when you think about how many devices are requiring a network connection today, that's barely anything. IPv6 uses 8 hexadecimal octets because it's 128 bits. There's 3.4 times 10 to the 38 addresses, which, AKA a lot, a lot. But if you're gonna change something in technology nowadays, you gotta be able to have devices on old systems be supported in the new systems, and that's just not really feasible right now, so that's why everything is kind of still IPv4, and IPv6 is still growing. Now we get to classes. Networks can be, basically these are just default, actually I should go over what a subnet mask is. So an IP address has 32 bits, right? And in order to find out what the network address is, you'll logically AND the IP address and the subnet mask. So a review of AND is 0 and 0 is 0, 0 and 1 is 0, 0 and 1 and 0 is 0, and 1 and 1 is 1. I don't think that makes sense to a lot of people, but if you have any questions, please ask. But the classes are designed to default to a subnet mask to easily identify how long that mask should be. Basically, it just tells us, hey, this is how big your network can be, and this is how many hosts you can have. So remember, the host portion is how many devices can be on a single network. A lot of people don't like subnetting, but this allows for more granular network sizes. So what you do is we borrow bits from the host portion, which is that first half or first portion of the IP address that's ANDed with the network mask, and we kind of just move some bits over. We don't actually move it over, we just kind of logically think about it. But that example there, 192.168.100 is a Class C address, which can normally assign only hosts in the 4th octet. But if we borrow 1 bit, we can make 2 smaller logical subnets, and that's the ranges they can assign to devices. Why would you subnet? Um, Usually, a network is created by border routers. So if you don't have a lot of routers, you can just logically make networks to divide out your task. In a company, you might have one subnet for HR, one subnet for engineers, etc. Still in layer 3, we have ICMP. This is how devices kind of figure out if an IP address is out there, and you can actually troubleshoot using this. So if you ever use the ping command, try to ping an IP address, this is the protocol that it's running. There's 3 kind of scenarios here. A device runs an echo request. The router's like, oh, I know where that is. It's over here. Then the receiving device will send an echo reply. I'm here. Yay, everything works. But if a router doesn't know where something is, like you're asking for a network that the router doesn't know, you'll get a destination unreachable. And packets have something called a time to live. So every time it hops to another router, it'll decrement. And if that time to live goes to 0, then that packet gets dropped. So this is really great for troubleshooting. A lot of times, if you misconfigure your router, you'll use this to figure out why your packets are not going where they need to go. Now, I said that IPv4 has a pretty small pool, but here we can assign what normally would be a public IP address to be reused in private networks. This is done on the router. So everything in a single private network would just pop out to the public internet as a single IP address. And this can be extended via port address translation, or PAT. We're gonna go over into layer 4 real quick, but basically you can map each private port to its corresponding public port, or have all your network come out of a single public port called overloading. If you're hosting like web servers in a private address and you have a bunch of internal ports, you can just have it appear to the public internet as HTTP. And that's pretty nice. Layer 4. Don't worry, people, we're almost done with OSI. Here we have TCP, which is a connection-aware protocol. There's a handshake to initiate data transmission. It ensures packets are delivered in order, and it also ensures that a recipient actually got all the packets you wanted to send. There's another protocol called UDP. Basically, you just use this one whenever you don't really care if something got received or not, but you want to do things fast. So I have this conversation here between a client and a server. We start the handshake with a synchronize. Then the server is going to acknowledge the synchronize and send another one. The client's going to be like, okay, we're all ready to send data. Yay. I send packet 1, you got packet 1. I sent packet 2, but something happened, the server didn't respond or acknowledge the second packet, so the client's going to try and send it again. And yay, the server got it. And of course, we want to close the connection. Both sides need to know that the connection is closed, so we see that finish flag, acknowledge the finish flag, and the connection is closed. There's a couple other ones. If a packet is sent out of order, like the client sends 1, 2, then 4, the server's gonna be like, whoa, I was expecting packet 3, why did you send packet 4? Please resend everything again. And also, if a server just isn't expecting data to be sent, like the port is closed for whatever reason, there's something called a reset flag, which will just stop a connection from forming. I was told that I can't walk around the room and I have to stay in front of this camera, and I was gonna do that. Perfect. Luke and James. Oh, it's with me? Okay. More.
Okay.
Okay, we're gonna demonstrate UDP. I just want, hey, where's google.com? Hey, where's google.com?
He has no idea if I got the packet or not.
Yeah. Okay, now we're gonna do TCP. Hi, James. I want to send some data to you.
Give me the pen. Okay.
Great. Here's a packet.
Cool, I got it.
Here's another packet.
Cool, I got it.
Here's a packet, but it's not the one you're expecting.
I didn't get it.
That's not what you're supposed to say.
Give me the packet again.
You're supposed to work. If a packet is
No, maybe
received
you're
out of,
supposed to throw the marker at me.
if you receive an out of order packet, you need to ask me to send everything again.
Send everything again.
Okay, here's packet 1 again.
I got it.
Here's packet 2.
I got it.
Here's packet 3.
I got it.
Okay, this one don't receive the packet. Here's packet 4. You didn't get packet 4. Let me resend it. Here's packet 4.
I got it.
All right, I'm done.
And then UDP again. Just throw it. Tilt it. See, he has no idea if I got it.
Great. TCP, UDP, transport layer, everyone. Ports. Ports tell you which service is running on a machine. A machine can have up to 65,000 ports. The first 1,024 are assigned ports. I have some common ones up there. And actually, fun fact, ports are separate for TCP and UDP. So SSH normally runs on TCP, DNS normally runs on UDP. You can flip-flop them. I don't know why you would, but you can. Registered ports, so people making apps can request to have the ports run on specific, can have their apps run on specific ports, and every computer will follow that. And ephemeral ports are temporary ports used for temporary things. So with the file transfer protocol, if you are running it in passive mode, it'll actually throw it into one of those really high ports and then close the connection right after that, because you don't need, you're just sending things one at a time. Yeah, if you recall, I said a couple layers in the OSI model were just collapsed into one layer in the TCP/IP. This is why I don't, session and presentation just are kind of there. They're the forgotten middle children. Not really middle, because I guess they're 5 and 6 out of 7, but they're just forgotten. Session is exactly what it sounds like. It manages the sessions between apps on different devices, and presentation just makes sure that everything's compatible across multiple devices. We get to the fun layer, which is the application layer. This is where a lot of people will see all the networking stuff, because this is what's presented to the user. So whenever you look something up on Google, check your email, transfer files, it's all happening at this layer. And we're going to talk about the concept of encapsulation. So there's 7 layers, but they are built in order. So you start with your data, and then you encapsulate it in your layer 4, your transport layer stuff that tells you which port it's on. Then you take all of that, encapsulate it in your layer 3, so it tells you where which IP it's starting from and where it's going, and then you encapsulate all of that in your Ethernet and send it across the wire as a bunch of bits. Then, when you receive it, you're going to work backwards. So you unwrap, you peel the Ethernet off, peel the IP stuff off, peel the transport layer stuff off, and you have your data. So at layer 7, this is where DNS lives, translates URL to IP addresses, because who wants to memorize 74.125.181.52 whenever you want to look something up? No, you don't, Casey. No. So you can type in google.com and it will automatically translate it to that IP address. And that's just one of Google's IP. They have like 100, not 100, but they have a lot. DHCP, whenever a new device connects to a network, it obviously needs to be given an IP address if it's not statically set, and it needs some other configurations, such as its default gateway, which tells it which router to go to, and also its DNS servers, which tell it where to look up URLs. So there's a 4-way handshake called DORA. The client will discover a DHCP server. The server will respond with an offer. The client can accept it with a request, and finally let the server know. So now that device has an assigned IP address and other configs, whatever is configured. Great. Congratulations, you now all know the OSI model. Let's build a network. Networks are defined with zones, and generally networks can't directly communicate with other networks without the help of something like a router in between them or some other direct connection. So, by the way, AN stands for area network. So PAN is personal area network. Then you have your LAN, MAN, and WAN. Just gets bigger and bigger. And it tells you where a network is functioning. A DMZ, or a demilitarized zone, sits between public and private networks. Think of it like your airlock or decontamination. Say you're hosting a web server and you have a database with some confidential information. You don't want to be exposing that to the public internet where anyone can just grab it. So you'll have, from your WAN, you'll put a DMZ in, you'll process any requests going to the web server and send that to your private network, and all your confidential data is protected. Here's an example. This is one example which I was trying to find one with 2 routers, because I think of routers as the border of each network. You can do this where you only have 1 router, and those are firewalls, the brick things. But usually the firewalls would be replaced by a router, or you can have a router and a firewall. So that just segments your public and private data even further. Okay, the fun stuff. How do you attack a network? First, we have a man in the middle. Guess what? If you have a bunch of bits going across an Ethernet cable, you can just listen to the bits and then decode it. For sake of convenience and usability, most enterprise networks just are really insecure. So make sure your data is encrypted, and also check that your data is not being changed in transit. At the end of an Ethernet frame, you'll actually have a checksum, so you can re-verify that checksum with the data that's in the Ethernet frame. Replay attacks. You can send previously captured data at a later time. So we have Bob here logging into the server, and this is in plain text. Now, James is over here like, hey Bob, that's a pretty nice username and password you've got there. Let me just take that and log in as you. And now the server thinks that James is Bob, and James can do whatever he wants in Bob's account. How do you prevent a replay attack? Introduce some random thing that you send with your data, and also encrypt your data. Spoofing, impersonate network details. This is actually, I realized this too late, but this example is actually showing poisoning. Spoofing and poisoning are similar things, but Here we have Google. James, I'm going to use an example for the rest of this just because you're red team chief. Okay. Someone wants google.com. James is like, I'm going to poison this DNS server and say, hey, google.com is at my server. But this would be spoofing if James straight up said, google.com is me. You can spoof and poison not just DNS, but ARP and MAC addresses. So you can say, you can change your MAC address and then poison an ARP table to try to direct traffic to go somewhere else. And then we have our denial of service and distributed denial of service, DOS, DDoS, overload a service that it becomes non-functional. A denial of service is usually one person or group attacking a server, and distributed just means there's multiple. I don't know the threshold, I just say one, but the server's like, oh my gosh, there's so many requests going to me, I can't handle all of these, blah, and it dies. Then customers will be like, hey, why can't I access this server? Because it's down right now. We're gonna go into some tools to help you in your networking journey. Firewalls block network traffic. There's a couple ways you can block IP ports or even specific apps if you have Palo Alto. I love Palo Alto. And there's something called a stateful firewall where it can actually examine where a packet is coming from and where it's going to. And it can block it based on specific patterns. But you can block your own traffic, so just be careful about that. And there's a lot of firewall implementations. So Linux has IP tables, NF tables, firewall D, and UFW. Windows has the Windows firewall. pfSense has something called pfCTL. I wonder what pfSense is. That's a pretty interesting term. But these are some commands you can use from various operating systems to help you troubleshoot. So I said ping was one that you can use. You can just ping an IP address and tell you, hey, does it exist? What's its status? You can also ping a URL, and that'll test your DNS resolutions. But netcat, you can write and read from layer 4 connections. There's some flags that you can set. Dig, query DNS, and see what IP address it's attached to it. I know that NSLOOKUP also does kind of a similar feature. Netstat and SOCStat displays active connections to your machine. If you run this command, oh, actually, who signed up for IRSec Blue Team? Whoa, love to see that. If you see something that's going back to the reserve ports thing, if you see a connection that's open on port, I don't know, 1, 2, 3, 4, 5, that's not a port that's usually open, and you might want to investigate that. Or if you see an active SSH connection and you're the only one that's SSH, but you see 5 of them, red flag. There's a tool to kind of see network traffic going across an interface. So that's called Wireshark. And it gives you all the data in this lovely format. So you can see source IP, destination IP, protocol, and what the data is. And Wireshark actually gives you all this lovely data that you can just dig through. And it does this for every protocol. So like I said, remember everything's encapsulated within each other, and Wireshark expands all of that and puts it in a linear format for you. So here's some TCP data. There's a lot here, but Wireshark kind of features all the same things for each packet. But make sure you are using Wireshark where you are authorized to. And you're using it for its intended purposes on networks you have permission to sniff on. pfSense. Okay. What is pfSense? An open source router appliance, ew, and there's less ew versions. It's basically just a bunch of PHP files on top of FreeBSD, which one PHP, two FreeBSD. Who wants to work with that, right? This is especially helpful for those of you doing RSec Blue Team, but there's a couple directories you should take note of. So etc rc.initial is when you boot up to pfSense, you'll see this on the next slide, but it'll give you a bunch of options to configure the router or do things with the router. That's the page, the file that it opens. And anything in that directory will just be run on boot. I would know the default files that come with pfSense, because if anything is, if there's an additional RC thing in there that's not default, that's gonna run every time you boot your router. It's probably not a good thing. pfSense runs on top of Nginx, which is a web server. So everything is in that directory there, user local www. And the config for the entire router is in slash, it's actually not /cf anymore. That's outdated because there's a new pfSense version, but it's just /conf/config.xml. And don't forget your general Linux stuff from Intro to Linux. Anything in etc will be configs for your various services, and check your logs. So the pfSense command line. This is what you see every time you console into a pfSense machine. And there's various options here, most of which you won't touch in a comp or in your every day-to-day life if you have a company that uses pfSense. Fun fact, option 3, reset web configurator password. That password is in, when you select option 3, it runs etc rc.initial_password. And the password that it resets to is hard-coded in the system, in plain text. So you can actually edit that file yourself and change the default password. So every time you run option 3, it'll reset to whatever you change it to, and it won't be pfSense. FYI, Red Team can also edit that file and change the default password. So if you get locked out and you run option 3, you don't know that password anymore. So be careful about that. And check your etc rc.initial for any weird things. Like 17, print the flag. That's not there by default. I would probably check what that is before entering in 17. Oh yeah. FYI, a cow drinks water. A cow drinks water. Some basic pfSense attacks, an interface can be brought down with the ifconfig command, but if you want to bring it back up, obviously just run ifconfig. The interface name was just usually like em0 or vtnet0 and put up. Know how the pfSense firewall works. You can actually, to undo that, you would do easy rule no block interface IP or unblock. Now, the MTU is the maximum transmission value of a packet. Basically, it tells any networking device, hey, what's the maximum size a packet can be? And if it's higher than the set MTU value, it'll get dropped. So if you see your interfaces are up in pfSense, but packets are getting dropped, I would check this MTU value. If it's really low, everything's just gonna get dropped and you won't even see it. And the GUI, like I said, all the web server pages are just PHP files, but it is really insecure. If you stop Nginx, it'll no longer serve the web pages. But you can bring it up with service nginx 1 start or 1 restart. The GUI. Yep, you can manage your users there. By the way, Red Team is totally a legitimate user. Keep that there. and you can configure your firewall rules. So the pages for these in the file system are user local www system underscore user manager and firewall underscore rules. You can do a packet capture from pfSense. And this one is a really fun one. It's user local www diag underscore command prompt.php. So like I said, everything is a PHP file for the GUI in pfSense. You can go into that directory, and if you remove this file, no one will be able, the web server won't serve it anymore, because this allows you to run commands directly on your pfSense box from the GUI. So little note for you blue teamers. And that about wraps things up. Networking, y'all.
How would you say someone that's in IRSec for the first time doing their first competition, how would you say someone could prepare to learn how to defend PFSense?
That is a great question. The question is, how would someone competing in IRSec prepare to use pfSense? Am I allowed to do like a plug for CCDC? Okay.
We're officially part of the club now.
Oh yeah.
It was unanimous.
So if you want to learn more about pfSense and networking in general, come to CCDC tryouts. Today we are starting week 2 of tryouts, but even if you haven't come to the info session or week 1, everyone's still welcome to join. Networking level 1, you'll learn how to set up a basic LAN, and then you'll move on to setting up a DMZ. And level 3 is you'll dive deep into the pfSense file system and secure it without using the GUI, which I think is a really good skill to have. Yes, the GUI is really useful, but it's also very insecure. If you have any other questions, please reach out. I love yapping about pfSense or networking in general. So yeah, come to CCDC tryouts. Yes.
This might be a weird question, but is there any other GUI you can like use if like download on like Linux or something and just try using it remotely or?
So the question was, is there another GUI you can use to access the pfSense GUI on another machine? Am I understanding you correctly?
Yeah.
You want to access? Are you trying to access the GUI from outside the pfSense box? Okay, so yeah, if you enter in the LAN interface address for or any interface address for a pfSense box in a web browser, you'll open up the pfSense GUI. It doesn't need to be accessed on that box. So as long as the box you are trying to access the GUI on is on the same network as the router, you can just enter in the router's IP address and you'll get the GUI. Any
I'm honestly confused about like what's the difference between like a network adapter and like a network interface?
network adapter is what you call the device on a computer, and network interface is the kind of logical equivalent of that. They do the same thing. One's describing the physical device. Oh, sorry. The question was, what is the difference between a network adapter and a network interface? The difference is there is no difference, but the network adapter describes the device. The interface describes the logical component. Yeah, the adapter is the physical connection, and the interface is what the router will send everything out of. Yeah.